In design and implementation, we're going to focus on the software design and software implementation. The implementation is the process of programming, basically. So you convert the design documentation, whatever you have, into the programming code so that it will be accessible on a platform. And software design is the process of defining the software model that you're going to follow, the architecture, the components, and also UML specifications. Now, UML diagram is quite oftenly used in system design. There are 5 different UML diagrams that we're going to learn throughout this course. These are activity diagram, use case diagram, sequence diagram, class diagram, which you already know class diagram from the object-oriented programming course. I assume all of you took object-oriented programming before. And finally, state machine diagram. So these 5 diagrams together, they form the UML specifications. And while you are not obligated to use every single one of them in a project, use at least one to organize your structure, to understand your system on the paper better before you move into the programming part. Okay, so you sit down, basically visually draw yourself a map before you sit down and code. And once you understand the system as an abstract, then you can move into the phase where you can implement it. So that is why the design is done, basically to create an abstract map for your software so that it will be available for you. So you can come back, you can refine it, you can reflect on it. So there are some specific steps that you need to consider in design. One of the most important steps is the architecture design that you're going to follow. Every software system has a software architecture, okay? And depending on the architecture that you're going to choose, the software services, even the way that you develop software changes quite a lot. Such as majority of the web services nowadays are based on distributed architectures, distributed systems. For example, a good example in this category is YouTube or Netflix. Netflix does not have a main server that governs everything, okay? It actually has local servers for every single country, and it works on a customer to business level so that each customer of Netflix connect to their local service. And from there, the TV shows are licensed. They know in which country which shows are licensed. And then those servers are connected to one another to get the information, usually more than one. So what happens in here is that there is no main master server that governs everything, although it is used to track down the process of other servers. It is their job is like a distributed system is used to manage the entire application. So this is why when you connect to the Netflix servers in Cyprus, it's quite different than in Dubai or different than in any other country. Even in between, we live in a small island, and I used to pass the Greek side quite often, and the shows that I went to see in my friend's place on his Netflix was quite different than the shows I saw in this side. So even just by changing your connection, not physically changing your location, but the way that you connect, you will actually see different kind of shows. And this is also true for YouTube. There are specific licenses for specific things in different countries, so they follow up a distributed architecture. Other architectures that you will come across are model view controller, often used in mobile platform industry. Also, many of the websites today, the responsive web development runs through model view controller. So basically, in this architecture, you separate how you display your data from how it is structured. So your data is stored in the always in the same way, but the way that you filter and display it changes. Today, we have absolutely no control over how to display the data to user, because they can access the same system from a tablet device, from a mobile phone, from their PlayStation or console, from their laptop slash tablet device, from their desktop computer. It's like hundreds of devices, millions of devices are connected to internet nowadays, and we don't have absolutely full control on their resolution, their hardware specification, their hardware usage, or whatsoever. We don't even know their screen size. So what you do in here is that you separate how the data is going to display from how the data is stored. And that is actually a good practice, because then you can adapt to data, the display of data, according to different devices. Okay, that is a very common practice that we follow in software engineering world. Another one is the tiered architecture, which we followed in object-oriented programming. We separate the persistency from business, and business from user interface. So a good architecture is actually combining the layered architecture with model view controller, and making sure that both architectures can be satisfied at once. And that will be a perfect solution possibly for internet web services that you offer, because it makes the data, it makes the software more manageable for developers. Also, it's also much more accessible for the users as well. So you can create more than one architecture. You can support more than one software architecture in a software. And to understand that, you need to decide it in the design and implementation phase. Again, the persistency of data is important nowadays in software world. We use mostly databases now to store persistent data. However, many of the software that you use today also rely on JSON web services, or XML, some older ones, or even cookies and files. So database is not the only way to store data. There are other ways as well. And it is an important step to decide how these will be supported in the application at early stages, so you will know. So making a differentiation between what to store in JSON, what to store in the database, what to store in the cookies file is an important part of design and implementation as well. The next one is the user interface. Now, this is a very big field nowadays in the world. Like, people dedicate, like, as I told you, explicit user experience researchers just to design their interface, because majority of the people nowadays, they only buy software and hardware products because of the interface itself, because of how it looks, how it responds, whether or not it is usable or not. At the end of the day, no one cares about how perfectly you wrote at the background programming code, how perfectly it is structured, how you define your variable names meaningful, stuff like this. Yes, as a software engineer, I would very much appreciate that you pay attention to optimization, you pay attention to keep your program tidy and it runs perfectly. But in the real world, the customer do not care about these things. They only care about how the program looks and how it feels, and that's it. So this is why, for example, when you look at the iPhone, the specifications for it, the hardware is probably not as powerful as a Samsung device. But because of how it looks and how it feels, many people still prefer Apple iPhone over Android devices, and it's a choice. So these are like, can also be a kind of like a brand for your company, for your production, and you want to keep that. to keep that pattern to yourself, such as, for example, years ago, when these mobile wars took over, I know that I remember that Apple took the patent of the home button, for example, so that no other phone can use that one button at the center, down center of the phone, home button. They should have to call something else. So they kind of like tried to create their own brand, their own interface design. So they're saying that, oh, this is our component, this is our brand, this is something we only use. And that comes forward, that actually stays in people's mind, and kind of like a big part of your interface design. Finally, you can design model for existing and reusable components and third-party services. This is more of a business model, I would say, rather than software design and implementation. But I think it should also be considered, because if you're going to use some reusable components, some third-party services, or if you're going to sell data that you gather from users to others, if you're going to put advertisements according to a machine learning algorithm based on user behavior at the background while they interact with your software, these are all steps that you need to decide before you jump into your implementation. Because at a later stage, if you come to a point and say, oh, let's apply a machine learning algorithm for the advertisements, it might be very difficult for you to track down the user behavior. Okay, it is always a professional step if you decide these things in advance. Okay, and you know that you're going to track down your user behavior, you know that there will be advertisements suggested on their interactions and so forth. While the users are actively using the software, it could be a little bit difficult for you to apply it, and it could be very, very expensive as well. So basically, you try to analyze what you need for the software development and keep this on track. Okay, that is the core part of design and implementation. Here's a very basic diagram to show how this is going to work. So you gather some design inputs, which is like the information you gathered based on requirements, the data description coming from the feasibility study, and so forth. And based on it, you take decisions in every single of those 4 categories. The components that you're going to use, the interface, your architecture design, and database. As I said, in big projects, these are explicit steps. Like, people step quite a lot of time actually to do the research to make sure that these are they are based on facts or statistical data. But in smaller applications, they would actually do research based on a small number of people or feedback around them, or just casual meetings with other people. So it all depends on the size of the project, but every single project, regardless of what they are, they will follow an architecture, they will have a user interface, they will use some components, and there should be a database design nowadays, because it's a big part of the persistency. Okay, that's how you keep the persistency of data mainly in today's applications. And finally, of course, once you have analyzed this design activities, there will be some outputs, such as you will come up with some decisions on your interface, the components you use, the database or other persistency, and the system architecture. That is a very, very basic of layout of how you can do the design of the software. Now, you have any more questions to me? No. Good. So I'm going to continue on. So in the next part, I'm going to continue on the software validation. The validation is also called the testing of the software, is where you cross-check whether or not you met the requirements of each stage in the development part. So basically, this is the part that I was talking earlier. that I said the requirements are not something you do and leave it and completely forget it. It is something that you return back and test it. So this is where it is done actually. You kind of like look at each step during the development of the project and you test them. There are mainly three steps, three stages of testing. These are component testing, system testing, and customer testing. The component testing is the unit testing where the developers actually test the system as individual components, such as if you have done a user interface or a business tire, you test it as a developer by yourself, like seeing the validation of data, whether or not it accepts numbers but not characters, such as any validation you do on the user developer side falls under this category. This used to be done separately from the development, so we had like unit testing tools, but they're not used explicitly nowadays. So basically most of the component testing is done while you develop the software, such as in the courses you had seen me several times that I write something and then I go and check whether the information is valid, making sure that the program doesn't crash, and provide some information if mistyped data is entered. So any kind of error handling falls under this category. Next, you do the integration testing. Now this time you do not test the module, but you test the system as a kind of like a whole. So now when you finish the user interface and the database part, you test them together, whether they could respond to each other, whether they can communicate with one another, whether the data is transferred correctly, or if you want to encrypt the data, you test that one as well, and so forth. Finally, the customer testing, which is also called the system acceptance testing, is done by potential customers or QA people in your company or in your team, and to make sure that this software is realistic, it is ready to go to the industry or to address to the user base. So when you complete your software and you come to present it to me to show that you have functionalities, the software runs as it is expected, we can say that is kind of like customer testing, because I am kind of like the last step before you air this software to your audience. So we can say that is the customer testing level. Now the testing has changed, as I said, over the years. We don't usually use explicit testers in most companies, especially in agile development. So majority of testing run through user stories and feedback nowadays. But these steps, regardless, they exist. And based on these steps, we have two different testing steps that we consider. These are Whitebox and Blackbox testing. Each one actually generates an output. Just like in the specifications part, if you remember, you were generating a report at the end. And in the validation part, you actually come up with a release of the software once the testing is done. So it's not like you do the testing and you are done. There's actually a version that comes that you reach to a milestone in the program, and you gotta support this. You gotta keep that specific version, okay? So the steps that go through from the initial development to its eventually release and evolution are called the software release lifecycle. Each software starts with a development release, and which is called a pre-alpha versions. So any step, any testing step that you do before you do a proper system testing is called pre-alpha version. These are the versions that software that are not formally tested and only covers the unit testing. So you do the kind of like the interaction maybe, and you do the separate testing, and like basically what we do in the module testing, the unit level testing, And the step forward, I will also say some of the system testing can be counted as the pre-alpha testing. So all these two categories, when you do it, it's called the pre-alpha testing. Now, once you have done that, an alpha version comes along, which is part of the white box testing. Alpha phase of a software is the first version that is officially tested. In this phase, software engineers usually use white box testing during the development. Once this is done, quality assurance people, as I told you previously, use Blackbox or Greybox testing. And Greybox testing is kind of like the combination between white and black box to test the software. When the software moves from white box testing to black box testing, this is called the alpha version. So now that you tested the software, you generated an alpha version, which is the system testing, and you are ready to show it to the potential customer base. This is called the alpha testing. So when you come to me and show me your presentation, you are basically showing me an alpha version of the system, because the only person who tested it is you, and you now kind of like trying to understand, you did maybe a very brief white box testing during the development, and you are now showing to it the quality assurance people or other teams, so that those team people can use Blackbox to test the software. So this is how white box testing works. This is a method used in software industry very often, usually unit level testing at the level of source code. So you kind of like generate a kind of like a list which you can tick and move on, like checkboxes. So you tested this, you tested that, and you put like a stamp on it like this: oh, tested, working. And then those things that are not working, you will put a cross and come back later to fix them. So it is kind of like, oh, does it accept the number and not characters, for example? And you will put a sign, you will put a tick to show that yes, it does. And the next one, when the fields are left empty, does it accept the data, or just gives a error message? If it gives an error message, if the fields are validated, you'll put a tick. When the program crashes, when you enter some user input that you are not supposed to do, such as you are selecting 31st of February, which does not exist in real world, if you didn't do the validation, you put a cross to it, which you come back later and fix it in the next test. So this is kind of like you create a bulletin points or a list you can tick or put a clash just to check on the the requirements, and these are actually generated on the requirements that you define at the beginning. The whole point of white box testing is the ability to know which line of the code is being executed, being able to identify what the correct output should be. So while you do not create a list, you do a lot of white box testing unintentionally, perhaps, or not knowingly, when you test your software. And at the end of the day, this generates an alpha version of your software. The black box testing is a method of testing software that the functionality of software is now is working, and it is possible for the user base to test the system as a whole. Now, the most important part here is that every level of testing, not limited to unit testing, integration testing, or system acceptance testing, should be tested. Okay, so you are not testing all those categories separately now. Now, in the early alpha version or pre-alpha versions, you can test the component, you can test the system, you can test the customer separately. But in the black box testing, these have to communicate. The system should be tested as a whole, and that is the big difference between white box and black box testing. In black box, you take it as a whole. In white box testing, you can test those components, those units, separately. It is possible to apply black box testing, however, at every level of testing, but this should be done as a whole. There's also something called Greybox testing. which is the combination of white box and black box testing. This testing usually takes place as part of the system acceptance testing. And the idea here is to search for any bugs that could cause improper structure, improper use of applications. So it's like this is like the refinement, this is like the optimization. Sometimes Greybox testing is actually done after the software is released, because if the company has a specific release date, they just release the software and then they do the Greybox testing to patch the software later. So it is called that the software is basically released with bugs, which often happens in interactive media. And then on the release date, they actually release patches to patch the software. So at the end of the black box testing, you go into a step called beta testing. And at the end of the white box testing, you go into a step called alpha testing. So an alpha version of the software is generated at the end of white box testing, and a beta version of the software is generated at the black box testing. Now, the software is usually released at the Greybox testing, and you just try to address the bugs and optimize the software. Greybox testing can continue as long as the software is in the industry, okay? So you kind of like iteratively can do this. Beta phase of a software is called betaware, is a feature complete version, but likely to contain a number of known or unknown bugs. This version of the software is sometimes called the demo version. Potential users of software are asked to participate at this stage to actively use the software and report issues. These people are usually called beta testers. Today, majority of software companies rely on their potential customer base to test the software and report bugs, rather than hiring testers to do this job, as this is a cost-effective solution. Like years and years ago, one of my first jobs that I got was actually a tester. And so there was an actually explicit testing team in the company that I work, around 25 people. And our job was just to test the alpha and beta versions of the software and make sure that the quality is supported before the software goes to the customer, so that we can discover these bugs before the customers do. But nowadays, this is not a very supportive, very conceivable method, although some companies still apply it because of tradition, because of their business model. Majority of companies, they do not actually hire, not the big ones, I'm talking about medium or small companies. They're not keeping explicit testing groups, but rather they rely on their customer base to test the software, because this is a more affordable way. So this is why the definition of software developer has become so broad nowadays, that there are no explicit system analyst, there is no explicit tester, there is no explicit people that will actually just go to work to test the software. You kind of like do these things concurrently, as I told you in the last chapter. So it's like they're all in a relationship. So just because you are a software engineer doesn't mean that you only have to understand from coding. So nowadays, the expectation of the industry lies upon, to understand how you could do a white box testing, how you could do a black box testing, to keep a record of what you update, what you don't update, to keep an organized structure for the testing phase and so forth. You have more than one role nowadays. It's not like going to a 9-to-5 job and coding all day. Your role is diverse, and you can kind of like shift it. So just to want to finish this chapter, if I can, and take up the questions at the end, should you want to. What is a prototype? A prototype is an initial version of a system used to demonstrate concept and try out design options. A prototype is something that is developed in the software that for developers to understand what they are developing, basically. So it's not something that you explicitly plan to release, or you are not trying to develop a software that will be, you know, the 100% representation of what you're gonna develop at the end, but rather it is something you develop like a small version, or a kind of like a mini version of what you're gonna develop at the end, to make you understand what you are trying to focus on. Such as majority of the 3D games nowadays, they kind of like, in some cases, they develop a small 2D version of it, just to understand how some of the physics would work in that interactive media. And this is a practice applied in many different platforms as well. Instead of developing a full software, you kind of like focus on one aspect of it to develop your understanding of how that specific features would be supported, and just to test those features as well. So prototype is not something that you only develop through the requirements or design, but you can also use it during the testing to understand, for example, how physics would work, how a specific data will be sent throughout the web services, or something else. Okay, how an image processing would work on a specific device. So all these are like small part of the portion of the program that you're gonna develop at the end, and they are just there to help you understand the requirement validation, to test what you want to test. Okay, that is the sole purpose of prototype. But prototype is involved in every single step. It is not only involved in testing, it is not only involved in requirements. It could be used in the design phase, it could be used in the development, even in evolution. You can use a prototype to understand how you can expand that software. Such as a user might suggest you to do something regarding your mobile program, sorry, and you are not quite sure if you can support that feature or how it will look in that specific user base. So you develop kind of like a prototype to see what direction your software would go. And this will also allow you to check the errors in a limited scope. And you can also focus on what you want to deliver in a more reliable and secure way, rather than just directly implementing it into your program. So a prototype can be used in all stages, such as you can develop in the plan part just to see how things gonna go. You can define the functionalities. You can test your program through the prototype. You can, as you can see, you can even evaluate new prototypes just to see the direction you can take up from there. The final step that I would like to talk today is software evolution. This is where the software sometimes is called maintenance, although I see the evolution part more often. This is an expensive and crucial step in software development. It is probably the step, as I told you, that will never ever stop. Software is an ever-changing industry, and as soon as you stop applying the change, you risk your software to disappear from the industry. So your software must always evolve and change based on the user data, of course. You do not suddenly decide, oh, let me add an orange button today. That's not how it works. You take the data from the user, the feedback, you look up the user stories, you analyze a pattern there. If you see a pattern in user responses, such as specific tools are not working or they need an extra feature, you try to focus on those user needs and deliver in the next version. And if you don't do that, because of those users, probably more users will suffer from the same lack of options. As soon as a new software comes as a rival to yours, they will move to that one because that one supports that specific features and you do not. It's a very competitive business, so it's very important to adapt and address the user needs as soon as possible. Understanding and coping with change nowadays is a very important part of software industry. Those software that are adapting to the ever-changing industry requirements are the ones that are leading in this sector. Such as I told you several times before, Facebook wasn't the first social environment. There had been many social environments before Facebook, like MySpace, High Five are the ones that I remember right now, and none of those stayed in the industry more than 10 years, but Facebook did. And the only reason is because they cope with the change very well. It's not like they are the geniuses of this industry. I don't think so. But one thing that I appreciate, that Facebook never stops changing. They always add new features. They are addressing the user requirements, and they are evolving constantly. One of the last thing, I saw your hand, Darlington, but I want to finish this part. One of the most important things that I would like to talk in this section is that software evolution is very expensive and difficult. Such as if you want to apply a machine learning algorithm, which is something that came out in the last 6-7 years, to an existing software, that means you have to go through to, you know, explicitly into your software and change a lot of fundamental things. And you also need people that understand from that technology how it is applied and so forth. So it is an expensive thing to understand what the user requires at the next stage, how this can fit into your business model, how can you use this software to earn more money from it. They are all very expensive steps because new technologies emerge every day, and it is not always conceivable, it's not always foreseeable for us to apply these changes. Now, Darlington, if it is short, I'm going to take your question, and if not, I'm going to stop actually the video now and take the question at the beginning of the next session, because I'm running out of time again, because I have the 40 minutes threshold here. So I'm going to end up this session and record it and create one more session, probably around 20 minutes, okay, and take up your question at the beginning of it. All right?
Okay, you can take it at the beginning of next.
All right, thank you. I'm going to invite you again on Big Blue button and see you in a while. Thanks.